Good morning, dear students. I just welcome you all to the Physics Department, Digboy College. In today's video lecture, I am going to discuss about the linear differential equation of second order with constant coefficients. So let us begin. General form of linear differential equation of second order is given as d square y by dx square plus p dy by dx plus qy is equals to some function r, where p and q are constants and capital R is a function of x or some constant. Now in this second order differential equation, if you see this d square by dx square and d by dx, these are called as differential operators. Okay, so let me discuss little bit about the differential operators. Let me go to the new page. Okay, you please just note down this. Now you must know about the differential operators. So let me discuss about this. So differential operators are what? Simply this, d by dx. See here, this can be any function, okay? We don't bother for this. But if you see this type of form, so this is nothing but the differential operator and it is represented by capital D. So if I write this second order differential operator, it will be what? D square. Similarly, if I write d cube by dx cube, I have missed here square. Okay, it will be what? D cube. So simply you must know this is the differential operator, and if you take the second order, it will be d square. If you take the third order, it will be d cube. In this way it will go on. Okay, now if I write dy by dx, so can this be written as dy? Yes, of course. Can I write d square y by dx square as d square y? Yes, certainly I can write this. So in this way we can represent this d square by dx square in the form of differential operators, that is d square. So the general form of the differential equation will become as general form will be what? It will be simply d square y plus p dy plus qy is equals to r. Certainly I can write this, okay? Or in more general way I can write what? If I take y common, it will become d square plus p dy plus q whole thing bracket close, y common is equals to r. So these are the different ways to represent what? Second order differential equation with constant coefficients. Okay, so this is also a way, this is also a way. So in question you may get any kind of the form and you have to understand that. Now let us see what kind of solution we are going to get for second order differential equations with constant coefficients. The complete solution of such differential equations can be given as the sum of complementary function, which I can write in short c dot f, plus particular integral. In short we write p dot I. So complete solution. Complete solution means what? I am finding the solution of y. So y will be equals to the sum of complementary function plus particular integral. And in your syllabus, particular integral is there, and that's why I have to discuss this whole thing. Okay. Now let us at first understand how to find complementary function. In order to find complementary function, we have to take the RHS of the second order differential equation equals to 0. That is, what was the second order differential equation? This was the second order differential equation. Okay, so here this is the RHS part. This RHS part I am going to take equals to 0. So for finding complementary function, d square y plus p dy plus qy will be equals to 0. So this is the way how do we find what? Complementary function. Now if suppose m is the root, if small m is the root of this equation, then this equation can be written as m square y plus p m y plus qy is equals to 0, which can be further written as, if we take y common, it will become m square plus pm plus q whole thing y is equals to 0, or it will become m square plus pm plus q is equals to 0. So this is what? So this equation is called as auxiliary equation. Auxiliary equation. Now this auxiliary equation can be solved in 3 ways. This auxiliary equation can be solved depending on the nature of root m. Okay, depending on the nature of root m. So root means what? Solution. So here the solution of this auxiliary equation can be defined in, so the solution of this auxiliary equation can be written in the form of 3 cases. That is case number 1. If suppose the nature of root is real and different or unequal. Root is real and unequal. Suppose this is the nature of the root. Since it is a second order differential equation, we know that there will be 2 roots, m1 and m2. Okay, so if m1 and m2 are 2 roots, then and these 2 roots are what? Real numbers, remember, okay, and they are different, not equal. Then complementary function is y is equals to c1 e to the power m1x plus c2 e to the power m2x. Let me make you one more thing clear here. Always remember, for second order differential equation, the solution of the complementary function is given as y is equals to some constant c1 e to the power mx. Okay, so this is the solution of a complementary function. Now this m is what? It is the root. Since it is a second order differential equation, we are having two roots and we have to check the nature of the roots, whether they are real or unequal, whether they are real or equal, or they are imaginary. And depending on the nature of the roots, we will have different types of solutions for the complementary function. I think it is clear to you. Okay. Now, case number 2, roots are real and equal. In that case, what will be the solution? So if m1 and m2 are two roots, then complementary function is y is equals to c1 plus c2x whole thing bracket close e to the power mx. So this is the complementary function here, remember, for the real and equal roots, and this is the complementary function for real and unequal roots. Okay, so these two cases you must note down. Let us see the third case, that what will be the complementary function if our roots are imaginary. So case number 3, roots are imaginary. So if the roots are alpha plus minus I beta, so this is a complex number, remember. Alpha is a constant, beta is a constant, and I is some imaginary number. So wherever you get this I or this type of format, it is a complex number, remember. So if the root is a complex number having imaginary number I, then complementary function is y is equals to c1 e to the power alpha plus I beta x plus c2 e to the power alpha minus I beta x, which can be further written as c1 e to the power alpha x into e to the power I beta x plus c2 e to the power alpha x into e to the power minus I beta x. So I can take e to the power alpha x common here. So e to the power alpha x is common, and I am left with c1 e to the power I beta x plus e to the power c2 e to the power minus I beta x. Now from De Moivre's theorem, I hope you know that according to De Moivre's theorem, e to the power I theta is equals to cos theta plus I sin theta. I think you know this from De Moivre's theorem. Okay. So this was the De Moivre's theorem, which you know already. Now, if I apply the De Moivre's theorem here, I can write this as, let me take a square bracket, c1 cos beta x plus I sin beta x plus C2 cos beta x. So it's here minus, so minus will come here, minus I sine beta x, bracket close, which can also be written as e to the power alpha x c1 plus c2. I'm taking just common, okay, c1 plus c2 cos beta x plus I c1 minus c2 sine beta x. So this c1 plus c2 and c1 minus c2 can be treated as again another constant, okay, which I can write as this is equals to e to the power alpha x. So in place of c1 plus c2 I will write a, which is another constant again, cos beta x plus, and in place of c1 minus c2 I can write b sine beta x. So this is another form of the complementary function. So you can write the complementary function in this way or in this way. So these are the two ways. Either you can write in this way or you can write in this way. So both forms are correct, and according to the need we write. So most often times we use this, remember, because this is more simplified form of the previous one, of this one. So you can use this or that, but you please try to use this only because this is more simplified one, okay. So this was all about the complementary function. So till now we have learned about the theory part of this second order differential equation with constant coefficients. Now let us apply these theories in some practical examples. Let us solve some examples. Suppose we have the question that solve d square y plus dx square minus 8 dy by dx plus 15y is equals to 0. Suppose this is the linear differential equation or second order differential equation that we have got and we are asked to solve. So what we are going to do here, if you see, this is in the format of what? This second order differential equation, which is equals to 0. So here r is 0 here and q is what? 15, p is what? Minus 8, and rest of the things I think you can just understand. So I will just compare with this equation. So since here r is 0 and this is the left hand side of the second order differential equation, so from this we can get the solution of the complementary function. So I will write here directly what? Here let me rub this first. Solution. Here auxiliary equation is, so for auxiliary equation just omit y from all the sides, okay, from all the terms, okay. So d square minus 8d plus 15. So this is my auxiliary equation and this auxiliary equation is equals to what? 0 here. Always take auxiliary equation in this form, that is the right hand side should be 0 and the left hand side should be these terms excluding what? Y. Quadratic equation, and we can solve the quadratic equation. So this can be solved in this way, that is d minus 3 plus d minus 5 plus do the rest of the steps by yourself, because I think you know how to solve a quadratic equation. So here I'm getting what? D is equals to 3 comma 5. So these are the two roots of this D. So these are the two roots, okay, 3 and 5. Now since these roots are what? Real, okay, there is no I, so they are real roots and they are different, they are not equal. So first case will come here. So since, I will write what here? Since roots are real and unequal, therefore complementary function is what? It is y is equals to c1 e to the power m1x, so m1 is here 3x plus c2 e to the power 5x. So this is the complementary function of this linear differential equation, second order linear differential equation. So this is a very simple example. Let us say another example. Suppose we have got the question that solve d square y by dx square minus 8 dy by dx plus 16y is equals to 0. So this is the question. So what will be the solution? So at first we'll write what here? Auxiliary equation is, what is the auxiliary equation? I think you can understand here, no? It is d square minus 8d plus 16. This is equals to 0. So if you simply solve, you will get what? I think it is whole thing square, that is d minus 4 whole thing square is equals to 0. So here you can see d minus 4. D minus 4 means d is equals to 4 comma 4. So here roots are equal, real and equal, okay. So case number 2 will be applicable here. So therefore the CF complementary function is y is equals to e to the power, c1 e to the power 4, c1 plus c2x e to the power 4x. Why? Since roots are real and equal. So since roots are real and equal, we have written the complementary function as this. Also, I would like to mention you one thing, that if your r is equals to 0 in any of the second order differential equation, then you must remember that the complete solution, if r is equals to 0, then complete solution is equals to complementary function. That is y is equals to complementary function. So this is the complete solution of this type of second order differential equation where r is equals to 0. Okay, that's why till now we are only finding complementary function, whatever problem we have done. We are not finding particular integrals, remember. So if r is not equals to 0, in that case we have to find our particular integral. But if r is equals to 0, then only we need to find what? Complementary function. So here the solution, so I will just make it in box. Therefore complete solution is what here? Therefore complete solution is y is equals to c1 plus c2x e to the power 4x. So this is my complete solution. Let us see one more problem, and little bit difficult one. Okay, suppose we have the question that solve d square plus 2d plus 2 whole thing bracket close y is equals to 0, provided if x is equals to 0, then function y will be what? Equals to 0, comma y is equals to, y dash means first order differential equation. So y dash, when x is equals to 0, then it is equals to 1. So these are the two conditions given to us. In any question, suppose we have these two conditions, that if f of x is equals to 0 is 0 and f dash of x equals to 0 is 1, then what will be the solution of this type of second order differential equation? Let us try to solve this. So solution. So here again, at first we will write what? Auxiliary equation. Here auxiliary equation is d square plus 2d plus 2 is equals to 0. Now since it is a quadratic equation, so I will solve in accordance with the quadratic equation. So we know that solution of quadratic equation is given as d is equals to minus b square. So what is b square? What is b here? This is the b. So it is 2 square plus minus root over b square. So again 2 square minus 4ac. So 4a is here 1 and c is here 2. So 4 into 1 into 2 by twice of a. So here a is 1. So I've written 1. So this is the way how we solve a quadratic equation. I think you already know this. So it will be minus 4 plus minus root over 4 minus 8 by 2, which is equals to minus 4 plus minus root over minus 4 by 2. Now we already know that imaginary number I is equals to root over of minus 1, or you can simply write I square is equals to minus 1. So this is what we know about a imaginary number. So we are going to apply this concept here. So it will be minus 4 plus minus root over of, so in place of minus 1 I can write I square. So 4I square divided by 2, which is equals to what? Minus 4 plus minus 2I divided by 2. So you can further simplify this and you will get minus 2 plus minus I. So this is what we are going to get. Therefore d is equals to what I can write? Minus 2 plus I, comma minus 2 minus I. So these are the two roots. Okay, so therefore since roots are imaginary, therefore complementary function is y is equals to e to the power, what is alpha here? If you see, alpha is minus 2. So minus 2 x bracket close a cos, what is beta here? Beta is 1. So I will simply write x plus b sine x. Now by using the conditions that were provided to us in the question, that is for x is equals to 0, y will be also 0, right? So for x is equals to 0, let this be the equation number 1. For x is equals to 0, y of 0 will be what? 0. So in that case, e to the power minus 2 into 0, a cos 0 plus b sine 0 is equals to 0. It means what? It will be e to the power 0 is 1. So I'll be left with only a cos 0 is equals to 0, or a is equals to 0. So I'm getting what? My constant a is equals to 0 here. Fine. Again, if I go to the second condition, again a dash of 0 is 1. So what will be my a dash? So differentiation of y here, y of 0 is equals to 1. So differentiation of y is what? It is e to the power, sorry, I'm writing alpha here. It was minus 2x a cos x plus b sine x is equals to 1. And I will be putting here what? X is equals to 0. So if I just differentiate this, I will be getting here e to the minus 2x is, I will take this in this way. I will first differentiate this. It will be a minus sine x plus b cos x plus minus 2 e to the power minus 2x, and it will be a cos x plus b sin x. This is equals to 1. So if I put x is equals to 0, it will be e to the minus 2 0 2 into 0, and again it will be minus a sin 0 plus b cos 0 plus minus 2 e to the power minus 2 into 0 a cos 0 plus b sin 0 is equals to 1. So this can be further written as, so this will be 1, it will be 0, I will be left with b minus 2 a is equals to 1. We have already found that a is what? 0. So b is equals to 1, since a is equals to 0. So we have found the value of b, we have found the value of a. A is equals to 0 and b is equals to 1. Now we will simply substitute these values in equation number 1. Putting values of a and b in equation 1, we get what we are going to get. Y is equals to e to the power minus 2x. So a is 0, simply I am left with b. So sine x. So this will be my, therefore the complete solution is y is equals to e to the power minus 2x sine x. So this is the solution of this differential equation. So for today, let us stop here only, and I hope you have understood. If you have any doubt, please put in the comment section, or you can WhatsApp me, or you can call me to clear your doubt. So that's all. Thank you.